Okay, hello everyone. I welcomes to all in our lecture series on error function. That is your ERF function of x. Error function is an integral which is represented as 2 by root pi integration from 0 to x e to the power minus t square dt. Here t and x both are dummy symbols. Okay, in this lecture series we are going to discuss these topics. First topic is your definition and characteristics of error function and complementary error function. Second topic is your derivative of error function and complementary error function with corresponding questions. third Third topic is your integration of error function and complementary error function, and then last topic is your some miscellaneous questions. Okay, these topics or this lecture series is very much essential for B.sc Physics Honors University students for their university examinations as well as other different entrance examinations like JAM, CUT, CPT, etc. These topics are belongs to NEP syllabus, that is your National Education Policy syllabus. Okay, so let us start our first topic, that is your definition and characteristics of error function and complementary error function as our lecture number 1. Lecture number 1, now we are going to discuss this topic, definition and characteristics of error function and complementary error function. Okay, so let us start. In this lecture, first we have to define the error function and complementary error function. Then we are going to go for their characteristics. Okay, here error function is an integral. I'm going to define the error function. Okay, error function which is represented as ERF function of x is an integral as like gamma and beta function. Okay, is an integral which is defined as here 2 by root pi 0 to integration from 0 to x e to the power minus t square dt. And here you have to remember x and t both are dummy symbols. Here error function of x integration from 0 to x. Suppose error function of u we are going to write, then the integration will be 0 to u, and here t maybe can be written as y itself, y square dy. Okay, likewise complementary error function, likewise complementary error function which is written in this format, that ERFC for complementary. Okay, here ERF is there, here ERFC function of x is also an integral, which is defined as what, 2 by root pi. Here just integration limits will be changed. The integration limits will be x to infinite. Lower limit will be x, upper limit will be infinite, e to the power minus t square dt. As I told, both x and t are the dummy symbols. Okay, so here the limits, lower limit is your 0 to x for error function. For complementary error function, the lower limit is your x, upper limit is your infinite. Now we are going to go for the characteristics of error function and complementary error function. Just put the heading characteristics. First one, error function of 0 equal to 0. It is very simple that we can prove it here itself. We have to prove it. The error function of 0 is 0. How? Here you can see, we know that in general error function of x is written as here integration, sorry, 2 by root pi is there, 2 by root pi integration 0 to x e to the minus t square dt. We have to find out error function of 0. That implies error function of 0 will be written as what? 2 by root pi. See, here x means the higher limit is x. Here 0 means higher limit will be 0. E to the minus t square dt. So here upper limit and lower limit both are same. Hence this integral value will be 0. That implies error function of 0 equal to 0. Okay. Okay. Now we are going to go for our second characteristics or properties, that is your error function of infinite equal to 1. Error function of infinite equal to 1. Now we are going to prove it. Here we know that error function of x equal to 2 by root pi 0 to x e to the power minus t square dt, right? Now we have to find out error function of infinite, right? That implies error function of infinite will be how much? Will be 2 by root pi 0 to infinite, right? E to the minus t square dt. Okay, here this is your gamma function itself. This integral is in the form of gamma function. May you remember, already we have been discussed that, see, first I have to write this one. This can be written as, this integral also can be written as, here I am going to write, wait, here 2 by pi 2 by root pi 0 to infinite. Here it is 1 is there. Okay, so instead of 1, what we can write? We can write t to the power 0 into e to the power minus t square dt. So instead of 1, here I written t to the power 0, and this integral is nothing but your gamma function. May you remember, in our special integral lecture series we discussed, you just follow that lecture series, special integral lecture series. In that lecture series we discussed, if we have this type of integral 0 to infinity x to the power n into e to the power minus ax to the power m dx, this value will be how much? It will be 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m. Already we have been discussed. Okay, you just compare this integral with this integral. Here limit is your 0 to infinite, here also 0 to infinite, and here n, here you can see n is your 0, and here a is your 1 and m is your 2. Okay, here minus a x to the power m, here minus 1 is there. Okay, 1 t to the power m, m means 2, right? So if I am going to compare with this integral, between this integral and this integral, we can found what? N equal to 0 and a is your 1 and m equal to 2, right? So this integral value will be how much? Is equal to 2 by root pi. You just put it, write it in the bracket itself. Okay, these things already we know. This much you put in the bracket, it will better. This much you put in the bracket. So here this integral will be 2 by root pi 1 by m. Here 1 by m means 1 by 2 into 1 by a to the power, a means 1, 1 to the power n plus 1, n is your 0 plus 1, 1 by m, that is your 1 by 2. Gamma n plus 1 by 2, that means gamma 1 by 2. Okay, so here we found 2 by root pi into 1 by 2. Here 1 by 1 to the power anything is your 1, and gamma half we know root pi. So finally here 2 got cancelled, root pi got cancelled. Finally we found what? That implies error function of infinite equal to 1. Okay, hence it is proved. Now we are going to move our third characteristics. Third characteristics is this one. Error function is a odd function. We have to prove error function is a odd function. Just write it. Error function is an odd function. Is an odd function. That means we have to prove error function of minus x equal to minus of error function of x. This much we have to prove. Okay, we have to prove this much, because if we know if fx is a odd function, that means f minus x is nothing but minus x. So here error function is odd function, we have to prove means error function of minus x equal to minus of error function x. Okay, so here proof, we have to prove with this. We know what error function of x is nothing but 2 by root pi 0 to x e to the minus t square dt, right? Hence error function of minus x, error function of minus x will be how much? 2 by root pi 0 to minus x e to the minus t square dt. This is minus x. Okay, okay. Now consider t equal to minus u. Let consider t equal to minus u. That implies for this integral, okay, that implies dt equal to minus du, and here if t equal to minus u, obviously u equal to minus t. Now we are going to calculate the limits, new limits for t equal to 0 for the lower limit. That implies here t equal to minus u, so obviously u equal to 0, right? For t equal to minus x, if t equal to minus x upper limit, that implies u equal to how much? Here if t equal to minus x, so obviously here you can say this one, if t equal to minus x, u equal to x, right? So same thing we have to write, u equal to x. Now the above equation will be, that implies error function of minus x will be equal to 2 by root pi. Here the limit will be what? 0 to x e to the power minus, instead of t what we have to write? We have to write minus u square into, instead of t we have to write minus du. That implies error function of minus x, here minus du can be taken, minus can be taken outside of this integral, 2 by root pi 0 to x e to the power, here minus u to the power whole square means u square itself minus u square into du. I told initially this t and x are dummy symbols, so here u also dummy symbol. So if I'm going to consider this integral is nothing but error function. So that implies error function of minus x will be equal to minus of error function of x. Hence it is proved. Okay, okay. Now we are going to go for our next property or characteristics number 4. that error function of minus infinite equal to minus of error function of infinite will be how much? Will be minus 1. This is straight, already we have been proved here. Error function of minus x equal to minus of error function of x, and error function of infinite already we have been proved that 1. So error function of minus infinite will be how much? Minus of error function of infinite, and error function of infinite we found 1. So this value will be 1. Okay. Okay. Now fifth characteristics or property here, error function of x plus error function of minus x equal to 0. Obviously, how it is? Here you can see it is one step proof. Error function of x plus error function of minus x is your what? Minus of error function of x according to third characteristics. So this will be error function of minus x will be how much? Minus of error function of x. So will be this value will be 1. So error function of x plus error function of minus x will be 0. Now sixth property, one of the important property or characteristics, that is your error function of x plus complementary error function of x equal to 1. Okay, this we have to prove it. This is one of the important property. If this question will ask, for 3 mark. Okay, so carefully you just watch the characteristics, this sixth number characteristics or property here. Proof starts. We know, you have to write, we know, see here the PDF format of this note I'll upload, and link I'll give in the description. You have to download for your exam point of view and prepare for your exam. Okay, we know error function of x equal to how much? 2 by root pi 0 to x e to the power minus t square dt, right? Here for this integral you just put t square equal to p, put t square equal to p, small p. That implies 2t dt equal to dp, right? That implies dt equal to dp by 2t is equal to, here you can say t square equal to p. So t will be how much? Root over of p. So this will be dp by 2 into root over of p, right? Now we are going to check the new limits for t equal to 0. That implies p also will be equal to 0. For t equal to x, higher limit is how much? X. That implies p will be x square. Now the above integral will be how much? That implies error function of x will be equal to 2 by root pi is there. Integration limit will be how much? 0 to x square, right? 0 to x square. This e to the power t square we consider as p. So e to the minus p, and dt we found dp by 2 root over of p. Okay. Okay. Now here this can be written as, here 2 got cancel. This is your 1 by root pi 0 to x square limit is there. Just write as such. Here root over of p can be written as what? P to the power minus 1 by 2 into e to the power minus p dp. Simple. Okay. Okay. That implies here the most important step, this one, error function of x equal to here 1 by root pi is there. Here this limit I am going to write with the uh, with superposition, with the addition format. How I am going to write addition or subtraction format? How it is? Carefully just watch. 0 to infinite p to the power minus 1 by 2 into e to the power minus p dp. Okay, then minus 1 by root pi x square to infinite. Lower limit is your x square to infinite p to the power 1 by 2 into e to the power minus p dp. See here, for this integral the limits are 0 to x square. I just segregates in this format. The limit here 0 to infinite minus x square to infinite. It will give you the limit 0 to x square. How it is? Here you can see. You draw this figure in your note itself. Here this is 0 and this is your infinite, suppose. Okay, we want 0 to x square. Suppose somewhere this point is your x square, this point is your x square. So here 0 to infinite, this distance, if I'm going to subtract this distance, the whole distance, and I'm going to subtract this distance from the whole distance, then I can found 0 to x square, this distance. Okay, same thing here it is written in this step. 0 to infinite whole distance minus x square, this distance, x square to infinite, then we can found 0 to x square limit. Got it? Okay, you just draw this figure in your note. So that implies error function of x will be equal to 1 by root pi. Okay, and this value is your gamma half. How it is? First here we have to write it will better. Here 0 to infinite, here p to the power, I can write what? Half minus 1. Half minus 1 is nothing but minus half into e to the power minus p dp. Okay, and second integral you just write as such: 1 by root pi x square to infinite p to the power 1 by 2 into e to the power minus p dp. Okay, so here error function of x will be equal to 1 by root pi. Here this integral is in the format of what? E to the power minus x to the power n minus 1 dx. 0 to infinite, that is nothing but gamma n. So here instead of n we have half, so gamma half is nothing but root pi minus, here you just write as such, this integration x square to infinite p to the power 1 by 2 into e to the power minus p dp. Okay, that implies here error function of x will be equal to, here gamma half is nothing but root pi. So root pi got cancelled, you just write gamma half, and this gamma half value is nothing but root pi. And second integral is your x square to infinite p to the power minus 1 by 2 into e to the power minus p dp. Okay, now here root pi got cancelled and you can get 1. Here you can omit the step. Here I written 2 steps. This step is not required for your exam. Direct you just write this integral value. This integral value is your root pi, gamma half root pi, and root pi got cancelled, and you can get this one. That implies these 2 steps are not required for your exam. Okay, error function equal to 1 minus 1 by these 2 steps you just omit in your exam. P to the power 1 by 2 minus 1 by 2 e to the power minus p into dp. Now we are going to evaluate this integral. Okay, we are going to just rearrange in the form of complementary error function. Okay, for that what we have to do here, put put p equal to u square. Okay, so this dp will be equal to how much? 2u into du, right? And the limits here, the new limits for p equal to u square, that implies u, sorry, p equal to x square, no, x square is your lower limit, x square is your lower limit, right? So p equal to x square, for p equal to x square, that implies, if I'm going to put x square over here, p equal to x square, that implies u equal to how much? X. Okay, for p equal to infinite, that implies u also will be infinite. So above integral will be written as here, that implies error function of x equal to 1 minus 1 by root pi. Here the limits will be changed, uh, x square to infinite to x to infinite. Here p we considered as u square, right? So here instead of p we have to substitute what? U square to the power minus 1 by 2. Okay, into e to the power, p is your u square minus u square, and dp is your how much? 2u 2u into du, right? So 2 is the constant taken outside, that implies error function of x equal to 1 minus 2 by root pi x to infinite. Here you can see u square to the power minus 1 by 2, that means this value is your 1 by u, and this is your e to the power u square into u du, right? That implies we found error function of x equal to 1 minus, here u got cancelled, this u and this u got cancelled, and we found 2 by root pi 0 to x e to the power minus u square du. Already I told this u, x are dummy symbols. So instead of u we can write itself t. So e to the power minus t square dt also we can write. So here this integral, if I'm going to write like this, 2 by root pi x to infinite e to the minus t square, because u is your dummy symbol dt, this is nothing but your complementary error function x. Here complementary error function x we written like this. Initially what we written? We written 2 by root pi x to infinite e to the minus t square dt. So this integral is nothing but complementary error function. So that implies error function of x equal to 1 minus complementary error function x. Okay, that implies error function of x. This is one of the important characteristic or property always you can found in your exam for 3 mark. Complementary error function equal to 1. Okay, so you just remember this characteristic also required to solve different questions. Oftenly this proof also you can found in your exam. Here you can see many steps you can omit in your exam. Okay, I told that these 2 steps are not required, you can omit. Okay, now we are going to go for our next property or characteristic, that is your 7th one. Here complementary error function of x plus complementary error function of minus x equal to 2. Here proof starts. We know from 6th property, that is your complementary error function of x equal to 1 minus error function of x, this one. Here this is your 6th property. Here what we found? Error function of x plus complementary error function of x equal to 1. So obviously complementary error function of x will be equal to 1 minus error function of x. Here I written, that implies complementary error function of minus x will be equal to 1 minus error function of minus x. Now both side of this equation I added this one, error function complementary error function of x, and here complementary error function of x. Okay, so that implies complementary error function of x plus complementary error function of minus x will be equal to 1 here plus error function of x here. Error function of minus x, because the error function is a odd function, we know error function of minus x equal to minus of error function of x, right? So here error function of minus x will be minus of error function of x. So minus minus plus error function of x, this one error function complementary error function of x. Here according to sixth property, complementary error function of x is nothing but 1 minus error function of x. So here according to sixth property, I written a complementary error function of x equal to 1 minus error function of x. So here error function of x and here error function of x both cancelled, and we found error from complementary error function of x plus complementary error function of minus x equal to 1 plus 1 2. Okay, hence proved. Okay, here we completed the characteristics or properties of error function and complementary of error function, complementary error function. In our next class we are going to discuss derivative of error function and complementary error function with corresponding questions in our next class, that means in our lecture number 2. Okay, so thank you so much for watching this video. Thank you.